Bonjour. Hope everyone is restored after the first night. My name is Federico. I'm the founder and CEO of Evmos. Evmos, for the ones that don't know us, is interoperable EVM. We are based on the Cosmos ecosystem, but we're expanding the EVM into the rest of the EVM ecosystem, enabling full interoperability between smart contracts. And today, I'm going to talk about how we are expanding the capabilities of the EVM with our interoperability technology. Oh yeah, I need to turn it on now. Perfect. So the EVM. So the EVM standard is what right now supports all the smart contract. It's a powerful piece of the stack of the Ethereum network that allows the smart contracts to be compiled and then the bytecode translated into the virtual machine and execute these state transitions. But the EVM, more broadly as a narrative, has been increasingly growing, and today we can see that most of the TVL in the entire blockchain ecosystem is located in EVM chains, making it very compelling for new developments, new chains to be built using this piece of the stack. And so today you can see here there are more than 150 EVM chains today in production that are accumulating most of the TVL, like these from July 1st, Ethereum 62%, Tron 13%, BSC 7%, and so most of the TVL lives in these EVM chains today, even though there's different ecosystems that are trying to tackle different VMs or different protocols, application-specific blockchain narratives like Cosmos, etc. But with this EVM chains expansion also comes at a trade-off, which is user experience and developer experience. You can see here how cumbersome it is to constantly go to your wallet and switch networks. Depending on where the application is located, right now all the different teams that are deploying into these different EVM chains have to manage the entire ecosystem. They need to do redeployments, they need to manage infrastructure, and more importantly, operationally speaking, they also need to manage the communities. And for a user perspective, even though you can use the same wallet and the same address on these different EVM chains, you still need to go and switch your network, which is not the best UX. And so right now, Ethereum has this narrative of migrating to L2s for scalability. So you have the EVM as like the vertical stack where it supports all the smart contracts. And for scalability purposes, they are using layer 2s that are settling into Ethereum. So Ethereum is the settlement layer. But there's this major issue that is going on right now of like, as these layer 2s grow over time, there also needs to be some sort of like interoperability protocol that can allow them to compose and to build on top of each other's DeFi applications. So for example, what happens when you have certain components that are useful for your application but are not on your layer 2, then what you need to do is like go and look on Ethereum, go and look on other EVM chains for these same applications that you already have on Ethereum but are prohibitively expensive for you to run or for your users. So there's all these narrative going on, and even MetaMask on an institutional account was saying that one of the major limitations of the EVM at the moment is that in terms of interoperability, there's no clear standard for interoperability between smart contracts, and thus all the advances that all the other ecosystems are doing at the moment poses a threat in terms of like user experience, narrative building, composability, etc., that Ethereum today doesn't have. So that's why I want to expand on this topic today on how can we achieve EVM interoperability while at the same time retaining the same great properties that the EVM has today. So taking a step back, why do we need interoperability? We talk a little bit about the DeFi Lego, so like these pieces that allow you to compose smart contracts built on top of each other. For example, if you have a lending market, you, of course, need an oracle for the different pricing. So Ethereum allows you to do that today very effectively. But again, it has some limitations in terms of transaction fees, network utilization, security, etc. Interoperability is also very, very important for accessing liquidity. Right now, and some people might disagree with this, but right now, the liquidity, even though it's mostly on the EVM, as you saw before, with 155 EVM chains in production, this liquidity is fragmented. So you have the Ethereum token, like the Ether or the USDC, that is currently fragmented, and you have like wrap versions or like bridge versions on other EVMs. So this liquidity, even though it's been minted on the same protocol, it's not accessible to the applications that are deployed on these other EVM chains. For example, Celo, that is migrating to the EVM, might require additional sources of liquidity that are not available on Celo, and thus constraining the user experience, constraining the developers in terms of their requirements, specifically on DeFi applications that require this deep liquidity. And again, user experience, having to manage all these accounts, even though you can use the same address, is painful user experience. And so interoperability is relevant, extremely relevant for these three reasons. So going to like, what's a wish list when we are talking about EVM interoperability? So of course, accessing the state. That means reading and writing on the EVM virtual machine. So you have like the read, which involves queries, querying the state of different smart contracts, querying different states of like generally the protocol, the core protocol, and then writing transactions. So how do you able to compose? How do you able to call different smart contracts? And this involves not only smart contracts that are EVM compatible, but also layer 1s and app chains that are, for example, on Cosmos, all your other layer 2 chains, and other VMs. This involves Solana VM, Cosmos WASM, which is like the WASM standard on Cosmos. You can also have interoperability with different smart contracts that are on Avalanche, etc. So this is very important for achieving these goals of interoperability. So on Evmos, we're trying to pave the way for this EVM interoperability while retaining the basic properties and benefits that the EVM offers today. How are we doing that? By changing this multi-chain strategy, which is like deploying the same instance everywhere, into having like a cross-chain narrative where you only need to deploy once and then manage and access all the liquidity, all the composability, like this DeFi Lego that I was mentioning today, and while retaining the best user experience that you can today. So Evmos allows you to have the programmability and composability of the EVM while retaining the sovereignty and interoperability of the Cosmos ecosystem. It's what we call programmable interoperability. So how are we doing this? How are we achieving EVM interoperability? It's through the IBC protocol. IBC stands for Inter-Blockchain Communication Protocol, and is a canonical protocol that is widely available in the Cosmos ecosystem that I was lucky to be part and a member of contributing team. I shipped the IBC core protocol primitives, and then I was part of the team that shipped the IBC protocol in production in 2020. So using that knowledge and using the knowledge that we built on the EVM, we're now able to offer different scalability solutions, horizontal scalability, while retaining these properties that I mentioned before. So the IBC protocol, how it works, you basically have two chains, a relayer that is running live client verification proofs, so you can verify state that it has been executed in two chains. So here you have the validator set, the two different chains, and in the middle you have a relayer that is verifying this. I have a chart that I will show you afterwards how this works at a technical level for the ones that want to take a picture. But going back to the important, right? The important thing is like user experience. How can we acquire more developers? How can we enable new use cases? So IVC applications, they usually have like two categories. One is for single interactions, and another one is for repetitive interactions, periodic interactions. So IVC applications right now, you can, for example, execute a cross-chain swap, like set a set of instructions to a counterparty chain. So for example, if you have a smart contract on Evmos, you can execute a swap on Osmosis, which is like a cross-chain deck, like interchain DEX on the Cosmos ecosystem, swap that token, get the token back, and then execute something programmably. So you can define the logic. After you receive the token, I want to do this or that with the token, and so you have this composability aspect that is really relevant. Then there's this other narrative that is starting to develop now, because this is a recent development in the Cosmos ecosystem, which is interchain accounts. So interchain accounts has different, the main difference with the other use cases that I said was a one-off trade, execute something that the user has defined. Interchain accounts, what it allows you is to perform recurring actions on the counterparty chain, and then maybe every now and then transfer back to the original chain. So what this allows you is like, for example, you can use Evmos to manage liquidity on Ethereum. So you can like run all your computation on Evmos, and every now and then just like perform an action on Ethereum or perform an action on another chain. So this is really relevant for these type of use cases, and which will enable, again, interchain composability through our IVC interoperability. So, okay, we talk about the EVM interoperability, we talk about why it's important, and we talk about how we're using IVC and the different, the two different cases where you have like one-off interactions or like repetitive interactions where are very frequent. How we are enabling that is through our EVM extensions. So our EVM extensions, what they basically allow is to, technically speaking, for the ones that have deep understanding of the EVM, it's stateful precompiled contracts. So traditionally on Ethereum, you have ETH recover to verify the private key and the signatures. And you have like other elliptic curves, etc. Those are stateless functions that you can interact today on Ethereum. But what happens when you want to access state, when you want to read state or write state on the core protocol, in this case Evmos, on the Evmos EVM? These EVM extensions, what allow us is to access those core Cosmos functionality like staking, governance, IVC. You can manage, again, interchain accounts, and you can access all these interoperability functionality through very intuitive Solidity AVI interfaces. So you don't need to, like all these gibberish that I'm telling you about IVC and how it works, you don't need to care about that. You have an AVI interface, you can access it, you can interact with it. It's audited, it's secure, it's been battle tested in the Cosmos ecosystem. So for developers, it's really simple to interact with this Cosmos primitive. So what this allows you is that now you can enable StakeFi. You can build powerful DAOs that bake into the core Cosmos protocol, and you can build like new governance mechanisms. You can access IVC, you can access liquidity that is not available on Evmos, but is available on other chain that has been fragmented. And so the EVM extensions, what it allows you is to have these predefined smart contract address to access different Cosmos functionality. And then one major, besides EVM extensions, what we're trying to do is, okay, we talk about EVM interoperability as a broad category, interacting with layer 1s, interacting with layer 2s, and smart contracts. So what about application-specific blockchains? Sometimes a smart contract today cannot interact natively via IVC. So how do we enable application-specific blockchain functionality, those app chains that have their own business cases, have these different transaction mechanisms with Solidity? And that is what we call today Outpost. So these like smart contract interface that allow you to interact with the app chains. So today we're, in the next few months, we're launching two major outposts to two major ecosystem players in the Cosmos ecosystem. One is Stride. It's a liquid staking chain that allows you to stake any token and get a liquid staking derivative for that. So how this looks like for the users is that instead of having your Stride address here, you just have an Evmos address, and you can interact directly with MetaMask, opening the same application to 30 million users and even more developers that can compose with such functionality. So how this works on a technical level is that you have the Stride chain, or the Stride outpost on the Evmos chain. You can interact with Ledger, Kepler, which is a major wallet on Cosmos, MetaMask, and any other EVM wallet. You have the predefined address for the Stride outpost. You execute an EVM transaction. It converts that into something that the IVC understands under the hood on the core protocol, and it just sends the instruction to the Stride chain. And the Stride chain, what it does is like automatically liquid stakes that into Evmos through what it's called technically like these IVC middleware, and then you get on the Evmos chain, you get your liquid staking token. And that is a final interaction that you do. It's like a two-way interaction. And after that, you can also define your custom logic. You can define whether or not you want to like use that liquid staking token that you just received on a DEX, or you can like farm it. So it allows you to do all these different interactions today on the through this outpost model. And same with Osmosis, the same interface, only changing the Evmos, like the application-specific address to something that is EVM compatible, so like a hex address or the Evmos formatted address. And same, you have the outpost, you execute an Ethereum transaction, it routes it, sends the instruction to swap a token or to provide liquidity, sends the IVC transaction over to Osmosis, execute the swap or executes the liquidity provisioning. You get the token that you want, either the LP token or the token that you wanted to swap, sends it back to Evmos, and you can do something different based on your programmability on the smart contract. So this is a very powerful narrative. Like today, what we're enabling is like liquidity previously was constrained by the EVM. So you had this concept of TVL that I mentioned initially. That is like how much liquidity is on all the EVM chains individually. Today, with this functionality, you can access liquidity that is not available on your chain. It's what we are calling like total reachable liquidity or omni liquidity, like access all liquidity that is available in the ecosystem. And this, especially when you're launching a new chain, when you're launching a new smart contract, is really crucial because sometimes you don't have that deep liquidity requirements on your native chain. With this functionality, now you can access it. So we talk about writing state. We talk about how you can access EVM extensions, use IVC to interact with other layer ones, and how to interact via IVC with other application-specific blockchains. What about reading the state? So there's like a powerful application standard on the Cosmos ecosystem that is called interchain queries. It works in the same way as that I was describing before. It's like you define a set of instructions, what you want to do on the counterparty chain. In this case, what you define is a packet, an IVC packet with a data instructing the receiving chain to read some part of the state on a specific smart contract or in a specific part of the state. Here it's using the bank module that handles the balances, but you can literally define any smart contract data that you want to read on the Evmos chain. And it reads that state, sends a response back with a proof so that you can actually verify it, and then you execute something else. So again, interchain composability, this narrative of accessing state, either reading or writing. And what this enables is, for example, you need an oracle for your lending market. It's not available on your native chain. How can you access an oracle service that is deployed somewhere else? And this, for the ones that are involved in business development here, or for the ones that are starting their EVM chain here, you might have run across that it's extremely expensive to get these deployments on your EVM chain. So every one of these 150 production EVM chains has interacted with one of the major players in terms of like these DeFi primitives, these DeFi components that enable this composability on the EVM layer on a single virtual machine. But it costs like 1 million per deployment, then recurring costs for maintenance. So with this, you can like strip all of that. You can access liquidity that is not available on your chain. You can access services that are not available on your chain. So like we're completely shifting the narrative from pay to play to something that is like accessing all that via interoperability. Like it literally can save millions of dollars in like integrations. So interchain queries, what it allows you is to access state that is not available today on the EVM. But on this being realistic, like there are some limitations about IVC. We saw last week how the multi-chain hack happened and how vulnerable these different bridge architecture are today. The main problems with IVC is that the core primitives sometimes are not applicable to all transfer protocols. Sometimes you just need a simple like, I'll have a very rough solution for transferring tokens from one blockchain to another. I don't need a huge security mechanisms, and that's what Ethereum is using today. And then for the packet data encoding and decoding, so this information needs to be understood on the sending chain and the receiving chain, so that they can like understand the instructions, execute them, and send them back. It's expensive. If you're running on an EVM chain, you don't want to spend most of your gas on decoding like packet data. So how do we support AVI encoding, RLP encoding, which is something that Ethereum developers can already, Ethereum smart contract can already understand. It takes longer innovation cycles because today the only way for you to build a smart an IVC application interoperable is to build your own chain. It's not available for smart contract developers. And so what we're introducing today is like instead of striping these like application layer, which is on the top, it's what you care, right? It's what you want to achieve by having this interoperability between smart contracts, layer ones, etc. But you don't need the channels, the connections, the clients. You want to wrap that around and have it available to you. That's a powerful narrative that we're introducing this year, which is called dynamic IVC. What dynamic IVC is a wrapper around all the core primitives of this interoperability protocol so that smart contracts can define, verify, and encode their own packet data. So what this allows is like, instead of having to wait for the next IVC application, you can define your own. And you can interact not only with EVM smart contracts on other chains, but you can build your own interoperability applications using this interoperability protocol. This is the first time that the Cosmos ecosystem, more broadly, is opening its doors of interoperability to smart contracts. So traditionally, you have a packet data with all these gibberish, sequence, source port, destination port, source channel. You don't need to understand that. The only thing that you care is the data you're sending over to the chain. And so what we do here is creating a Solidity interface on the AVI so that you can wrap that around, send an IVC packet with a sender. You have the destination that is already defined in the packet data, and you just send it to the destination chain. It gets handled there by the smart contracts. It gets verified. The smart contract itself sends the acknowledgement to the original sender chain, and you can handle your own interoperable application on a smart contract. This will enable EVMs to connect to each other, smart contracts to connect to each other, not only EVM or Solidity-based, but expanding the limits of the interoperability, expanding the capabilities of the EVM to possibilities and use cases that we haven't even enabled today. So we're really excited to be introducing this If you have any questions or if you're interested in building with this technology, specifically the EVM extensions, the outposts that are live today, reach out. And so the advantages of DIVC, again, faster pace of innovation, allows for smart contract interoperability, opens new use cases, and is cost-effective for applications. Thank you very much. And here's some resources. We have an academy where we have a few tutorials and guidelines. And here's our testnet faucet if you want to get started with this interoperability functionality on the EVM. Thank you very much. I think we have time for 1 or 2 short questions. Otherwise, happy to take them afterwards.
Thank you very much for your talk. How do you manage finality? Because like if you want to call some optimistic rollups or ZK rollups or like this, you have to wait sometimes before you have the finality.
Yeah, so it all depends on the finality that it has been implemented on the consensus level on the chain, on the destination chain, on the sending and destination. So on the Cosmos ecosystem and many other ecosystem chains, they use BFT. So that means like they have instant finality. So you can use just IVC, wait for one block, gets committed, it's sent over, and you don't need to wait for the finality. But as you said, Ethereum and other ones are using what's called Nakamoto consensus, which means that you have a probabilistic finality, that you need to wait a few blocks, or you have to set the parameter for the security that you want to send. And there's some teams already that are working on this IVC with non-instant finality. For example, the Polymer team is building something for Ethereum specifically, and we're planning to leverage these interoperability functionalities to not only access BFT chains, but also access Nakamoto consensus chains with probabilistic finality.
Okay, this will be the last question.
What's the read latency between 2 Cosmos chains?
Sorry, can you...
Sorry, what's the latency? How long does it take to read a value from another chain there?
The question, it depends. So like, for example, Evmos has like 4 seconds. Some of them have sub-second block time. And for example, Cosmos has 6 seconds. It's all configurable on the chain. So as long as all the validators define like a timeout for how long they need to wait for committing a block, but that's, again, depends on the configuration that the validators.
So that's an asynchronous read then, not a synchronous read.
It's not atomic in the sense of like, you need to wait for the acknowledgement to be sent back, and then you read the acknowledgement, whether or not it's success or a failure error on the destination chain. So you need to be able to like lock the tokens for a specific period of time. You receive the acknowledgement, and then you like unlock the tokens and continue your logic. But it's not that big of like a long latency. It must be less than what you have to wait today on Ethereum to like get one block confirmed.
Thanks.
Okay. Thank you, Federico, and
thank you very
everybody.
much.